Hello. My name is Pini Resnik. I'm from Resync, which is a green software startup. And before that, I spent quite a lot of years working with cloud native systems and founded Container Solutions, which was still is cloud native consultancy. So I'm involved in this ecosystem since before Kubernetes existed, so more than 10 years. And now we are doing something green around that. So that's sort of the next step, and that's the story. So first, do we really need to do that? I assume you're here, so you sort of agree with it. It's not a lot of people, so that's how it typically happens. So there is there's general understanding that something is happening around climate change, but it's still sort of very new and it's unclear how many people are committed to actual change. So the change is happening, and I'm not going to go into that and explain that, but basically we are on the way to climate change. Yeah. And it can be either very bad, or sort of reasonable, but we're already beyond the minimum that could be okay. And generally speaking, although most of the developed countries are actually going down in carbon emissions, so we are actively reducing carbon emissions, which is a good thing. But the world in general still goes up. This, by the way, is drop for COVID. It's about 5% of total emissions. When we stop traveling altogether, then we save about 5% of carbon emissions, and then we picked up the year later. So we are still going up. The main reason for that is countries like India and China. China sort of already reached the peak, so it will also go down, but we're not going down fast enough. That's the main story. That's as much as I'm going to talk about the general idea. If you disagree, I assume you wouldn't be in this room. So now a bit of our own problems, our own industry problems related to sustainability. So first, we are generating more and more digital services, digitalization, AI, whatever you call it, but basically, compared to today, we need to go all the way. We expect to double the IT industry by the end of the decade and potentially go 10 times bigger within 20 years or so. And in the same time, we need to reduce the emissions by 50% by end of decade and by 90% by 2050. So this doesn't fit, right? So how can we continue growing and in the same time reduce the emissions? The only way is to detach ourselves from that, right? Because if we don't, this will be the emissions generated by our industry. We're already at about 4%, anywhere between 3 to 5, depending who you ask. And pessimistically, we can get to 14% of the worldwide emissions. So we are actually by far bigger than airlines. And unless we do something about it, then that's the direction. And that's the previous talk was talking about, actually, every single talk is about AI and more data centers and more explosion in IT services. And in the same time, weirdly, we are only using about 15 to 20% of existing capacity, right? So the average utilization in the industry is below 15 to 20%. Yeah, so we build all that and we don't use it. Why is that? So the main story is because although in the past we started from sort of craftsmanship story, so everyone doing software, whatever way they sort of figure out how to do it in the beginning of the journey, then we sort of went into we cannot be so random. We have to create control and manage this thing. So then we created Waterfall. Waterfall became, when the internet exploded in the dot-com boom, then basically the speed of development, speed of delivery to the customer became essential, and the waterfall couldn't allow that. Right, so it was too stiff and too, slow, and we all know that, if it takes 6 months to provision a server, to buy and deploy a server, then you cannot do quick experimentation. So then we went all in on Agile. Agile, the main idea, although it originally came from Toyota system, but Toyota system is not Agile, it's lean, right? It's about cost of delivery per unit, right? So it's about optimization. Agile is about change of direction. Change of direction is essential for innovation, but it creates an amazing amount of waste. So what kind of waste did we create? So there are a few examples. There will be 3 screens of that, right? There's a lot of different types of waste. So the first one is absolutely unreasonable business requirements. Right, we are all talking about Kubernetes and how amazing it is and stable and how much resilience it can have, but do we actually need 4 nines, right? Almost no system in the world actually needs 4 nines. It's very expensive to achieve that. Most companies just do that, right? They just say that they do that. They don't do that because it's very difficult. Very few companies actually achieve this high level of availability. 24/7, do we actually need to be 24/7? If you're a European company and 99% of your customers are in Europe and they don't use it overnight, why does it need to be 24/7? Why can't we switch it off for 3 hours a night, right? There's no reason we need that. Latency, below 100 milliseconds, humans cannot even distinguish a difference, right? So it's in some cases, it's essential. We had a customer that had robotic systems that they had to have 15 milliseconds because that was physical restraint, because that's how long the thing took to travel from here to there. But in other cases, there is no reason for that. All that leads to a lot of overinvestment in systems that they don't need to be as good as we try to build them. And in a bank, often you would say, we cannot lose even a cent. This is not true. Banks systematically lose millions of euros. Systematically, right? It's totally normal for a major bank to lose multiple millions of euros in different transactions. It's just, it is what it is. Because the cost of not doing that is to invest in much better systems, which will cost more than that. That's the challenge, that's the trade-off. The other set of problems is over-provisioning. We basically, when we are in agile space, we solve all the problems we have, or majority of the problems we have, with throwing more hardware on the problem. If something is not working, let's change the VM from medium to large, to extra large, and never down, because down is difficult. Right? Very rarely we clean up unused hardware. So often you can see that the things are just working, or for example, we decided that continuous delivery requires a full testing environment for each PR, which is amazing, right? Then we can achieve that. But then we provision those full testing environments with maybe a dozen VMs, and then we do nothing with it, and then we keep it for 2 weeks, right? It's not helpful, right? I understand it's good to have this kind of availability to increase the testing, and do continuous integration. This is not continuous integration though, right? Because it's just pure waste. Just starting up things and not using them, or not shutting them down immediately when the test is finished, is a waste. And one of the sources of evil, almost all evil, in over-provisioning is reserved instances. We all say that reserved instances are great. Obviously, they provide stability, but this is the problem with them, right? So they provide stability means often you will commit upfront for 3 years of the same servers. It means that there is no incentives to reduce them, to switch them off. And, we already have them, so why wouldn't we use them? And also, when they are reserved, it means that the cloud vendor reserves them, right? It means that even if you're not using them, they're still keeping that capacity for you and not for somebody else, which leads to a lot of waste. Because what we want is to achieve something like 80, 90% of utilization on each server. From cloud vendor perspective, if you reserve that capacity, that's fine with them, then that's sort of the utilization of the server. But in reality, we're not using that capacity, so we're throwing it away. What would be much better if we would always use sort of spot instances, so dynamic instances, and they will die over time, which is fine, yeah? Then we will invest in restarting them, right? So recovery instead of over-provisioning. And then there is a lot of high redundancy, right? At some of the talks, one of the people asked me, somebody from audience, I'm from a bank, and we actually we have to do 4 redundant servers on each instance, right? So 2 data centers and 2 availability zones on each. But that makes no sense, right? It's like, when did they fail? And they don't really fail. And when they do fail, rarely, does the redundancy help? Typically not. So then why you keep 4 servers, right? And then wouldn't it be better to just start them up, right? If the recovery time is 5 minutes or 15 minutes, and you actually have that time, why wouldn't you invest in that more, right? Because then you just restart the system from the beginning and not waste the resources. And the last part is, is about actually not thinking about the full picture. So first, we invest a lot in development platforms. And those are amazing. They help to reduce the complexity for developers. But there is a flip side to that. When it's not complex and not difficult, people do more of it, right? And then they get this kind of infinite cloud illusion. Who thinks cloud is infinite? Anyone? I mean, eventually it's not, right? Obviously, we already run out of some of the capacity. There's physical stuff inside them, right? That burns the electricity that burns oil or gas or whatever. So it's not infinite, and we teach our next generation of developers to basically forget about physical boundaries and do whatever they like and expand as much as possible. And the development platforms basically allow them to do that, to basically expand as much as they like. And there's this the other one is not considering peaks of, like, Black Friday is absolutely terrible for environment, right? For many reasons, but in this specific context, everyone wants to do it, right? It means that we need to provision this peak capacity just for 1 day a year and then not use it anymore. Right, in many companies, you would see that we had a customer that they had 250 servers, and normally they would only use about 5 to 10 of them, right? And the rest are just reserved for 1 day a year. They don't even switch them off to save the electricity, right? So this is type of waste. Particularly interesting is Jevons paradox. So the idea is that when we make everything so easy, it doesn't reduce the use of resources. It actually helps to expand and use even more resources. So when we simplify the use of cloud, it actually leads to use of more resources, not less. You can read more about this. It takes a bit of time to understand, but I'll just move on. Okay, so to add to that, there are a few trends that will potentially affect the IT industry. And some of the trends are obvious, but I'm not trying to be like Oracle or something. But the first one is energy transition. So right now, we are using mostly fossil fuels for energy generation. Still, majority of our energy comes from fossil fuels. But the greener energy, wind and solar, are expanding. And the general idea is that it goes to replace effectively everything. Right? So at some point, it will be mostly wind and solar, while the fossil fuels will go to zero in about 15 years. It could be 20 years, but sooner or later it will happen. And it doesn't happen because of climate change. It happens because they're cheaper. They're dramatically cheaper. And this is just the beginning. They will be even cheaper. So this is hydro expanding a bit, nuclear expanding a bit, but effectively, we need to grow significantly in energy production. And in the same time, we need to replace the fossil fuels with wind and solar. This is the future of energy. The other thing is rise of AI. Now, I don't know if those are some numbers, no one can predict it for sure, but it's obvious that people will use AI. And using AI means that people can write code without being developers. People can use IT to do other work without being developers. So it means that there will be a big explosion of IT services. And there are two sort of sections here. One is actually querying AI or doing the work, and the second is training the models, and they are significantly different in their behavior. And there are a few others. There is edge. So Elon Musk is talking about using Tesla cars as edge compute devices when they are stationary. And generally, there is a lot of investment in expanding the cloud to the edge. There will be more attention to cost reduction because this 85% of unused capacity, it's a massive waste. And there is already sort of repatriation from the cloud because clouds they are amazing, right? They're amazing in the sense that they're better than what you do if you don't know what you're doing. But as you get better and better, then the cloud becomes overpriced and over-engineered. So you can create a custom solution that is actually better fit for you and cheaper. It's not generic, but you may not need generic. And there's definitely a lot of investment in sustainability, although it's not enough. I mean, again, this room is half of what was the previous talk. And unfortunately, this is still the case. Sustainability is still not the mainstream. But we need to start exposing the sustainability metrics so more people will actually pick this up. OK, so what should we do and how we can achieve a better balance? First, it's actually both agile and lean are essential. Agility is important in the beginning of product development lifecycle, right? So when we experiment, so cloud is great. You can put a credit card, provision few VMs, and just go for it, right? And it's also the waste is irrelevant because the scale is nothing, right? So there are no users, so there are very few users. So it's totally fine to provision few machines. There is no much waste on it, but the productivity increase is dramatic. On the other side, when we get to scale, like millions of users, it's crazy to change direction every week, right? No one is doing that. Like Gmail, when Gmail changed last time? When Google Search changed last time? They don't. They're highly optimized, and they care about maintenance and cost of anything, right? Everything. So what we need is sort of, over the period of maturity, transition from agile to lean. Lean means optimizing cost of maintenance, not cost of change. And we already have methodologies to actually do that, right? So, and Google is good in this because this is exactly their challenge. So they're trying to do both innovation and large scale. They have 8 billion customers, billion users products. So if they don't optimize for these products, then their maintenance cost will explode with scale, which is absolutely unreasonable. They will never be able to, like there is unit economics, right? So how much it costs to deliver a single search. If they don't optimize, it will be too expensive, right? But a lot of enterprises, they're already on the scale that is meaningful, but they're still not switching to optimized systems. So they're still in this agile mindset. So there is OKRs, SRE, FinOps, green software. And all those are focusing on actually lean metrics. And DORA metrics are more of a productivity metric. So I will just quickly go through each one of them. You can learn more about them later on, right? Each one of them available. But it's important in OKR, there is vision and mission and objectives and then key results. So it's not about availability in 4 nines. what the vision of the product, yeah, what the objectives eventually. And if objective is to serve European customers, during normal European working hours, where key results are high latency or low latency and high availability. It makes no sense. It has to fit in the business requirements. And yeah, so there is those 4 golden signals from Google. I mean, there's also what's important. There's errors budgets, right? So we actually allowed to make errors in this kind of systems, and we need to use those error budgets. Otherwise, we are overbuilding, overinvesting, right? So FinOps is just one parameter. It's not a goal. To save money is not a goal, but it's important to keep it in mind. And then there's green software metrics. So this is from Green Software Foundation. This is a general, an attempt to measure the impact on sustainability, which is a single number, like latency single number. And it includes energy consumed by a piece of software, or energy consumed by software, multiplied by energy carbon intensity in the grid, in that energy. So if it's coal-based or wind-based, plus embodied carbon, so how much it took to actually produce that hardware per unit of calculation. This is quite good metric. It's not easy to get, actually very difficult to get, but it could become a metric similar to latency or availability. And then DORA metrics are, I'll just move on, right? So, but again, it's important. It's important to keep in mind that the service level objectives are those who define the key results. The objective has to support the business need and not just be random, like we want to be 4 nines. It has to be relevant for the business. And then it needs to change over time. When the business requirements change, SLOs needs to change too. And then this is another artifact from Green Software Foundation, the maturity matrix, Green Software maturity matrix. The main message here is that it's not all or nothing journey, right? So it's not all or nothing jump. It's a journey. Yeah. So no one today is actually in the stage 5, right? Very unlikely. And also, if you are in like sort of between 1 and 2, you cannot expect to jump to the 5 immediately, right? So it's a journey. It's step-by-step journey. And it's important to do all of those things, not just carbon awareness, but also like reducing waste. And there's all kind of things that you can do. And this can help to sort of figure out what the journey is. It's good for education too, for education, self-education, and the rest of the organization. Right? In our experience, what we see is that the 4 steps need to be infrastructure. So this is Kubernetes event, and that's where most of the, like Kubernetes and around it, that's where most of the waste today. So in most cases, what we see from a typical company, we can save anywhere between 40 to 60% within almost no effort on infrastructure level. There is more to save on software level, on application level, and then there's a lot of other things you can do, but this is not really important. The main waste currently is over-provisioning and not switching off the hardware. Yeah, so, and if you ask me where to start, if you do want to start doing something about it, so the 4th step is to start learning. Yeah, so go to Green Software Foundation, there's a nice course about this. There are all kinds of resources. There's a book, Building Green Software. And then start measuring. Measuring is actually quite difficult these days, but still. And there's a lot of things we can sort of, when you leave the room, when your kids live in the room and they don't switch off the lights and you get upset. So in a way, that's what we need to start doing with our servers, right? Don't keep them running and try to squeeze more of, yeah, and like these are simple practices that we're all aware of, and they're very important. Just doing that would typically save 50% of waste in typical IT system. Yes. Yeah. Oh, here we are. Yes.
Yes, but I think most of people here are keen on working with Kubernetes, are satisfied with what it does, but I've noticed a problem with it, and that is a point that is missing on your previous slide. Software architecture. I think that the Kubernetes software architecture is a problem because it's no longer using principles that we have been using before, that is event-driven operation. Instead, it's doing polling. So it's always constantly comparing the state and the target it wants to achieve,
Right.
and that consumes a lot of energy. If you install a full-fledged Kubernetes cluster with all necessary tools, which results in a nice platform, and then let it sit around doing nothing, you will notice that it consumes a lot of energy already just doing nothing. This already?
Yeah, it's there's no straightforward. There is never a straightforward answer for that. But it's Kubernetes can help you to save energy too, right? So actually, majority of the waste is not on application level, but on infrastructure. So in this sense, Kubernetes is one of the biggest offenders because it allows to grow, right? Without like in Java, you would have garbage collection. There's not much garbage collection going on. You need to do it, right? So, but the energy, the energy overhead from the master nodes and all kind of overhead from the system itself, it's not always marginal, but typically it's marginal. On large scale, the applications themselves are supposed to be significantly more important. Now, if you are wasting a lot of resources by keeping an empty cluster with a lot of different things, it's the same thing as everything else I said, right? I don't think Kubernetes is inherently bad in this. It depends how you are using it, but right now the platforms are sort of encouraging you to grow and not shrink. Yeah, so it's a complex answer. We can talk more about this. I have 2 minutes to finish, so I'll just mention the tools. There's so the tools to measure energy from. So if you want to start measuring, then there are very few tools available. The one is Kepler, which is relevant for Kubernetes. It gives basically detailed energy consumption from each thing in the Kubernetes. It's quite complicated to run, and it has its own overhead a bit, but yeah, it's the only one available. There's another one called Scaphander, which is for physical hardware. It doesn't work in the cloud because it doesn't have access to the physical thing, and still a tool. Yeah, it also gives you energy. Neither of them give you actually emissions. They give you energy consumption. We built this tool called Ether, so to go to the next level, to actually collect the energy consumption and convert it to emissions, so we can connect to Kepler, or we collect it directly from OpenTelemetry system. And then there's a lot of things around code profiling. Like there are a couple of really good talks if you want to see them. Like if you want to learn more about profiling and line-by-line energy consumption, those are really good. But this is not where you should start, right? This is not for many years. This is not important because most of the waste is not there, but in infrastructure. And like there's languages, yeah. So there's C or Rust are very efficient, and Perl and whatever Python are terrible. But then again, you don't start in that because most of the waste is not there. Yeah, but people love this and get excited because there's like, oh, I'll switch to Python now, from Python to Rust. But it's not the point, right? And then, and the longer term is basically, we need to keep this kind of balance. So yes, cloud is great for innovation, but we also need to keep optimizing our systems, right? So continuously reducing waste, continuously improving, more dynamic scheduling, and very important, as green energy becomes more and more available, it's very spiky, right? So it has its own behavior. What we will need to do is eventually adjust our loads to the energy availability and resource availability to smooth this kind of behavior. And that's especially important for AI. When we train the models, we need to train them when the green energy is available, right? And then things like fast recovery over redundancy. Redundancy is an old way to do it, right? There is no, it still has its place, but there are better ways to do it. Yeah, and also, although I have a slide on questions, but I'm exactly on time, even a few seconds over. Maybe.
Thanks for the talk. A short question: when you talk about waste, do you mean both hardware production waste and the energy consumption waste? Because if you had the example where the company buys 150 servers and they utilize only 10% of it, they don't waste electricity, so to say. They only waste hardware production.
Okay, so there are quite few questions in this. First, both. So there's three things that are that define the not waste, but the carbon and sustainability of software. Right? So it's energy consumption or energy efficiency. It's embodied carbon, so hardware efficiency, and carbon intensity in the energy. Right, so carbon intensity doesn't depend, it partially depends. You can install your own solar panels, right? That's one way to do it. Energy efficiency means running less. But then when you say, I have 150 servers, are you switching off those you are not using? Because if you are not, they're still taking about 50% of the energy, even if they are idle, right? So that's why you want to really load them as much as possible. But on the other side, and on hardware side, like every time you buy a server, it depends on type of server, type of hardware, but anywhere between 15% to 15-20% for a server is embodied carbon over the lifespan of the server, and up to 85% for a laptop is embodied carbon. So it's carbon produced or emitted while producing the device. So yes, there's multiple levels of waste when you do that. And then all of that costs you a lot of money. Okay, thank you again.
Thank you very much, Miniki.